Okay, let's try problem 13.7.5t. As I recall, there's quite a bit of work for this one. Let's see. So there's 20, alpha's 5%. First, I want the mean, because we're going to compare each one to the mean, whether it's above or below, and create a run. So I open it in Stat Crunch. And do a summary stat on variable 1. Compute. Means 157.5. Okay, so now the null hypothesis is that the data are in random order, and the alternate is that they're not random. Always the case. The test statistic. Well, first I got to figure out the number of runs. So I go back to the data, and I have to create a new column. So for variable 2, I do data, compute, expression, build. Variable 1, add column, and then subtract minus the mean, 157. 157.5. Hit OK, and then put it in variable 2, compute. So variable 2 now contains the positives and negatives. Positive is above, negatives below. So if I just do the run, I got positive, negative, 2 positives, 1 negative, 1, 2, 3 positives, 1 negative, 1, 2 positives, 1 negative, 1 positive, 1 negative, 2 negatives, 2 positives, 3 negatives. All right. So the number of positives, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That means there's 9 negatives. 1, 2, 3, 4, 5, 6, 7, 8, 9. And the number of runs, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so that's the test statistic. There's 12 runs. All right, and now they want the p-value. Well, God darn it, the p-value. So we need a z for that. So we got to convert this g to a z. So we're going to need mu g and sigma g, which we can calculate using the 3 numbers that we have. P we'll call N1. N for the negatives we'll call N2. So I don't think StatDisk will do this. We could try. Let's see if we can try that. Open in clipboard. See, we don't have the differences. We'd have to create a whole column. I don't know. StatDisk won't be able to help us. It doesn't work with raw data. That's the problem. It only works with if I just look at it, runs rest for. See, it just looks for. If we give it the data we have, we could do that. This is the summary data. So see, it gives us the test statistic G, and then it gives us the critical values. The critical values are 6 to 16. So we're between the 6 and 16, so we're not going to reject. So the p-value is going to be larger than 5%. So going back to the calculator, well, first we go back to the problem. And what's the p-value? So if I open up the calculator, first I have to calculate mu. So mu is equal to 2 times n1 times n2. That's 2 times 9 times 11. That's 198. Divided by n1 plus n2, that's 20. Plus 1. So 10.9, that is mu. Sigma is a little more complicated. Sigma is the square root of a big fraction. So the numerator fraction is 2 times n1 times n2. We already know that's 198. And then times two times n1 times n2, 198, minus n1 minus n2, so that's minus 20. So that's the numerator. I think I need, you know what? I don't, well, I'll just put another parentheses. Divided by n1 plus n2 quantity squared, that's 20 times 20 is 400. And then times, oop, I put 4,000. Times n1 plus n2 minus 1, so that's 19. $2.153454996. 2.1535. We'll use 4 decimal places. Now to calculate z, oops, we got to take g, which is 12, minus mu, which is 10.9, and divide by sigma. 2.1535 should be close enough. So we get 0.511 to 3 decimal places. All right, so the p-value, let's do 5108. The p-value is going to be between the positive and negative, the tail values. So if I do a 1 minus, I do second vars normal CDF, and I do negative 0.5108, comma 0.5108. P-value is 0.609. Oop. The 3 decimal places, yeah. 0.609. Okay. So since the p-value is so high, it's way bigger than 5%, failed to reject. There's not sufficient evidence to conclude that the data are in an order that's not random. We can't accept the alternative. Can't support it. There appears to be no trend because the values are scattered above and below the mean. Okay, it's random. Okay, so that's problem 13.7.5. Dr. K over and out.